So significant quantities of metals will be needed for clean energy infrastructure and technology to support the global transition to net zero in line with the Paris Agreement. And the taxonomy explicitly recognizes that through including minerals mining and metals criteria. This is exemplified by the IEA's projection that under a below 2 degrees scenario, total demand for metals will materially increase. Some of the largest demand rises are likely to be driven by metals used in clean energy technologies and infrastructure, including lithium, nickel, and copper. However, under Australian 1.5 degree scenarios, including our reference scenarios, bauxite and iron ore production are projected to increase to 2050 and beyond, as aluminium and steel also remain highly important materials with a wide array of applications in the transition, including technologies, building, and infrastructure. So as a major minerals producer, Australia is well placed to capitalise on the global opportunities presented by demand growth driven by the global transition. The selection and bounding of activities and draft technical screening criteria for the sector have been developed in close consultation with a technical taxonomy advisory group, technical expert group, and also with industry stakeholders, including Minerals Council of Australia and the Chamber of Minerals and Energy of Western Australia and their members. In selecting these activities and minerals to cover in the first phase of the taxonomy development, we've kind of considered a few factors that are on the screen here. So the first is the Australian list of critical minerals and strategic minerals. Nickel and lithium are listed as critical minerals, and copper and bauxite as strategic minerals. The projected role of minerals in the transition, including their importance for key technologies and infrastructure, have also been assessed, and also the importance of minerals with projected stable and growing demand to the Australian economy. We've also thought about the Australian government's policy priorities for minerals and metals with reference to the transition, including the Future Made in Australia agenda and the critical minerals strategy, which has been a very significant starting point to us. And this has led to the initial selection of lithium, nickel, copper, iron ore, and bauxite. Just to note that bauxite has been added since the first public consultation in recognition of its importance to the transition and the Australian government's focus on low carbon aluminium supply chains under the Future Made in Australia agenda. Decarbonisation measures that can be used for other mine sites have also been included in recognition that there is a need to provide options to reduce emissions for a variety of other minerals that have a growing demand profile but are not explicitly included in this round of the taxonomy's development. So in terms of the first round of consultation, most respondents did assess the approach as credible, and there was broad support for the proposed decarbonisation measures, with respondents indicating support for support measures to be accessible for other minerals too, which I've covered off on. Support for the inclusion of renewable diesel as an eligible decarbonisation measure, which was a question we asked in first consultation, was also met with a resounding yes, providing that accompanied requirements to mitigate environmental trade-offs are also included. Respondents also suggested that we look at other sector pathways. So initially we'd been considering the Climate Work Centre's 1.5 degree pathway, which was based on the industry ETI project from 2022 and 2023. However, we've also looked in response to first public consultation at CSIRO's 2023 rapid decarbonisation scenario, which is a 1.5 degree scenario. And that has now underpinned the emissions intensity trajectories that we've put forward. Respondents did suggest including additional minerals, and to note, while this initial phase of the taxonomy has included bauxite as an additional mineral, others we hope will be included in time. Several submissions also provided constructive feedback about how the usability of the criteria could be improved, and I'll go through all of this in a second, but one of the comments that we got was that further clarity should be provided around what the emissions boundary is, and additional options included to provide flexibility in the green criteria. And the second was around how we situate downstream requirements for iron ore in the criteria. In first public consultation, we'd put forward downstream requirements for iron ore, recognizing that in 1.5 degree scenarios, there is necessity to channel more iron ore to low carbon iron and steel production relative to the baseline that we now find ourselves in. So just to go over the mining criteria quickly, in this round of consultation, there are 3 options we've included. So the first is we've developed an emissions boundary that's the crushed ore boundary is what we call it. So it includes extraction and it includes crushing, grinding and milling, but it does not include any further beneficiation processes that happen downstream between those processes and the forming of concentrate. With that option, there is also a scope 2 requirement that states that to meet the green criteria, the electricity, whether it's sourced on-site or off-site through the grid, has to meet 100 gram CO2 per kilowatt hour threshold, which is what we use in the electricity sector. The second option retains our approach in the first consultation. So in the first consultation, we'd included a mine site boundary that was mine to gate and provided flexibility. And we derived the starting point emissions intensity from the 20 percentile of best performing mines globally for that specific mineral, and then applied the steepness of the decline of that emissions intensity trajectory according to the scenario that we were using, which before was a climate work scenario, but is now the CSIRO 2023 scenario, which applies a little bit more flexibility in the 2020s and 2040s. That allows mine sites, just to be clear, some flexibility in how they meet it. So any mine site that meets within that emissions intensity threshold, but likely past that crushed ore boundary stage, can access that as a green criteria option. For those mine sites where neither of those options works, we have also included a percentage-based emissions intensity reduction. This stipulates that the mine site can begin from an emissions intensity value that they are at, but must reduce it by 4.2% per year, which is based on the Science-Based Targets Initiative's absolute contraction approach. So they must meet at 4.2% from the baseline that is set at their current emissions intensity value to retain green classification. When it comes to iron ore and bauxite, emissions intensity thresholds are also put forward corresponding to a boundary. So for bauxite, that is bauxite ore, and for iron ore, that is direct shipped ore. However, there was support in public consultation and in the taxonomy technical expert group to retain downstream requirements. And so we've made some changes while retaining those requirements. The first is that before 2030, the mine site must meet criteria addressing downstream interlinkages. So for iron ore, that's with low carbon iron and steel, and for bauxite, that's alumina and aluminium processes. But before that, for iron ore, the mine site has to be able to demonstrate either that the ore grade is compatible with current performant low carbon iron and steel processes, which primarily at the moment is the DRI method. So magnetite can meet that criteria before 2025, or that the mine site or general project is compatible with low carbon iron or steelmaking processes. And the same applies for alumina and aluminium processes. However, after 2030, that site must be able to demonstrate that the bauxite or iron ore is being sent to a low carbon or performant iron or steel or alumina or aluminium process. And we expect by providing that extra 5 years that it allows climate-related data that stems from climate-related financial disclosures, and also the Guarantee of Origin scheme, which the government has announced an intention to pursue for these 2 supply chains, to be established, and that future iterations of the taxonomy will be able to follow that. For those sites that do not meet the green criteria, we have offered decarbonisation measures, which is what I mentioned before, and they include eligible technologies, processes, materials, and or services that improve the emissions performance of an existing activity and bring it into closer alignment with the green criteria. So these measures are included for each of the minerals in scope, noting that R&D for iron ore is also included, which acknowledges the need to create low carbon iron and steel processes related to hematite. By and large, the rest of them are consistent and apply to the minerals in scope and also other minerals and metals that may not be explicitly within scope of the taxonomy. In terms of the use cases, so I did mention before that we had that percentage-based reduction threshold as an option. So that does not quite have all of the same options as the declining threshold options of A and B, which were at the crushed ore boundary or at the mine to gate boundary that stipulate an emissions intensity starting point. So the percentage-based improvement can be used for the reporting of CapEx, if the CapEx is related to an improvement, for transition planning, and also for sustainability-linked debt as the underlying sustainability performance target. But it's not generally used as an approach for use of proceeds green debt or the corporate reporting of revenue. Just to go back quickly to our emissions intensity pathways and our general approach to them, as I mentioned before, we do start from a 20th percentile of the best performing mines globally for the specific mineral in question. And then we set the steepness of the emissions intensity threshold declines that inform the green criteria according to a scenario. So the scenario we have chosen in this instance is CSIRO's 2023 scenario because it provides additional flexibility in the 2020s and 2040s. Just to give a quick update on kind of how we incorporated the feedback about scenarios, we did go back after the first public consultation and consult through a range of scenarios, including the TPI generic mining threshold or pathway, CSIRO's 2023 pathway, and ClimateWorks' pathway. And this just demonstrates that flexibility that the CSIRO pathway does provide, upon which we have based our emissions intensity thresholds. And that was it for mining. I might just pause there and see if there are any questions. It's quite a handful. Okay. In terms of the electricity sector, it's obviously considered in all scenarios, both global and Australian, as the key sector to decarbonise first, and with readily deployable options to decarbonise it. So the International Energy Agency's Net Zero 2050 scenario, which is our global reference scenario in the taxonomy, shows that the global power sector will need to be largely decarbonised by 2040 to enable the transition, and also projects that gas-fired generation peaks in the mid-2020s before starting a long-term decline thereafter. All reference scenarios, as you can see in this table, that we've used in the taxonomy, and that includes the 1.5 scenarios which explicitly inform our thresholds and also well below 2-degree thresholds, to kind of assess and compare, assume that electricity emissions fall to zero or very close to zero before or during the 2040s. And Australia is just one of those small number of countries where that is on track relative to energy growth. So the IEA's World Energy Outlook of 2024 found that we are one of the only countries in the world where low emission sources of electricity grew by over 20% in the last 5 years, outstripping electricity demand growth and leading to reductions in the use of fossil fuels. So Australia is very well placed to decarbonise its electricity sector as well. To be consistent with other taxonomies and the approaches that we also take in other sectors, emissions intensity thresholds aligned with credible global and domestic scenarios are crucial for determining the green criteria. As you can see in the table above, all of our reference scenarios show that by 2035, the emissions intensity or the average emissions intensity across those scenarios is 41.6 grams. And that then falls to an average of 8.7 grams of CO2 per kilowatt hour, and 2.6 grams in 2045 and 2050 respectively. The taxonomy following the EU approach and also the approach taken in the Singapore taxonomy and other reference taxonomies that have kind of guided some of our development decisions, is proposed to be calculated on a life cycle basis. This includes Scope 1 emissions intensity, and importantly for the electricity sector, upstream intensity values related to production considerations and manufacturing considerations. So in applying the transition methodology and, in line with the green and transition classifications that are outlined in the transition methodology report we released in 2023, we start from a starting point of, does the activity have a stable or growing demand in a net zero economy in line with a 1.5 pathway, which in the case of electricity sector activities is a resounding yes. And does the activity have a material Scope 1 and 2 emissions profile? And in the electricity sector, all of the activities that are readily deployable that have comprised what we've prioritized don't have material Scope 1 and 2 emissions, but do directly contribute to or enable emissions reductions in line with a 1.5 aligned economy. And so we don't actually have any transition or decarbonisation measures in the electricity sector because of the overwhelming maturity of options we have that are low or zero emissions. And so all of our criteria that we've included in the electricity sector are green and subject to, for the generation components, subject to the emissions intensity threshold criteria. And then for storage, there are types of storage that are included. And then for transition and distribution, there are additional requirements that are not explicitly all linked to emissions intensity thresholds, but do cover off on other things. There was a recognition in our first public consultation paper and also in responses to public consultation that we should consider the role of gas as an enabler to back up firmed renewables. And this is largely derived from AEMO's Integrated System Plan of 2024, which forecasts that the optimal development path is a renewable energy grid firmed by batteries and pumped hydro, and with flexible gas as the ultimate reliability backstop. So while AEMO's 2024 ISP projects that gas-powered generation capacity is going to increase, it does so around bifurcating the way that flexible and mid-merit gas are treated. So mid-merit gas, which is the more traditional role of gas in the NEM, is projected to continue to decline to negligible amounts by 2050. Flexible gas, which is providing that kind of backup role, is expected to increase in capacity terms. But its capacity factor, so the amount of time it's operating as a backup to firming, is actually set to decrease. So AEMO notes in the 2024 ISP that a typical flexible gas generator may generate just 5% of its annual potential. There are also some variabilities to these forecasts. So as AEMO's Gas Statement of Opportunity 2024 notes, in the longer term, the degree of investment in renewable electricity generation and also transmission and storage will all influence the overall need for gas to contribute to the currently projected firming requirements. So just to kind of run back over our selection of activities to AEMO's 2024 ISP, it is highly correlated with the generation mix. So the activities included in the taxonomy cover 98.6% of the generation and storage mix under AEMO's step change scenario in 2050 and almost 97% in 2040. The challenge with including gas is largely rests on two factors. So the first is that emissions intensities of gas-powered generation are higher than the 100-gram threshold than we will be starting at. So this graph on the left demonstrates, and this is derived from AEMO's 2024 Assumptions and Inputs Workbook, that the Scope 1 emissions intensity of an open cycle gas turbine and combined cycle gas turbine sit at around 450 or around in that ballpark for the closed cycle gas turbine and close to 700 grams of CO2 per kilowatt hour for flexible gas generation. And one of the challenges here, which is recognized in AEMO's system operability review, is that changing function of gas means that combined cycle or CCGT, which provide more mid-merit and baseload generation, are expected to be replaced by open cycle gas turbines, which are better suited to providing flexible gas-powered generation. And so that kind of that asset replacement cycle will entail the replacement of lower emissions intensity gas-powered generation assets, which is still well above even on a scope 1 emissions intensity basis, the 100 grams that we'll be starting with, which is on a life cycle basis. But the open cycle gas turbines are more emissions intensive. And that's a challenge for the taxonomy, which is an activity level tool, which does not make determinations about how often or how much that asset or activity is deployed. And so including it in an activity level taxonomy is a real challenge from that standpoint because of the function of flexible gas generation having a low capacity factor, but the taxonomy not having the ability to kind of set or verify that marginal utilization. And so we did look at how we could include it, but ultimately we have been consistent with the International Capital Markets Association's green lending principles, which came out this year, which said that green enabling projects should not lead to locking in high emitting activities relative to other technologically feasible and or commercially viable solutions. And that has framed and guided the fact that it's very much a challenge for us to include flexible gas-powered generation in an activity level taxonomy. So as I mentioned, we can't in the taxonomy account for the uncertainties around when and whether gas-powered generation is needed as backup firming. But we do understand that there is this system level role that's currently projected for firming. And so in the first public consultation, we've gone out and asked the question, would it be useful to provide kind of voluntary advice about how gas firming activities may be recognized and assessed within a credibly transitioning portfolio of storage and generation assets, particularly for financial institutions that may be making those decisions with utilities and with project developers. And the response that we got was yes. 76% of respondents said that that advice would be useful. And so in this second public consultation paper, we have put together a proposed set of advice, which really focuses on entity level. So transition plans is largely where that kind of nexus between system level assumptions and entity level investment decisions happen. And so we have guided and directed that advice towards the entity level within how you can look at a transition plan and recognize gas firming within that transition plan as part of a credible portfolio transition strategy. And just to reiterate that the exclusion of gas-powered generation as an eligible activity in the taxonomy for the reasons that I've mentioned before does not invalidate or exclude gas having a role in the taxonomy. So it can be used, it's a fuel, not necessarily an activity. And so it can be used in a variety of applications where there are not necessarily readily deployable alternatives. So we have kind of aligned with that future gas strategy principle that gas will gradually and inevitably support a shift towards higher value and non-substitutable uses. And we have not excluded gas, for example, in the manufacturing and industry sector, where it's acknowledged that in meeting emissions intensity thresholds in the short to medium term for some of those harder to abate activities, whether that might be hydrogen, iron and steel or cement, that gas can be used to meet those emissions intensity thresholds. And just to recap on some of those other points from public consultation, we have made some kind of clarifications to the technical screening criteria. So the first is with regards to solar criteria. We heard from a few responses that clarification was needed, particularly for off-grid renewable energy facilities, what the permissibility or allowance was for non-renewable backup generation. And so we have clarified that 15% of non-renewable backup generation is allowed at remote off-grid solar facilities. And we have also in the notes section of the technical screening criteria provided guidance on how to demonstrate compliance with that. We've also included run-of-the-river hydropower generation activities, being more clear around exclusions with the geothermal generation criteria, provided more detail about eligible and ineligible feedstocks in bioenergy generation criteria, which is closely linked to the manufacturing and industry sector, and included the refrigerant limits to ensure consistency with the buildings criteria in the district heating and cooling system activity. And we've also provided further detail regarding eligible low carbon gases and linking them to the manufacturing industry sector, where we now have production of biogas and other gas criteria there up for public consultation. Secondly to that, we have also developed that firming advice that I was talking about before. I might just stop there. Again, lots of words, lots of detail, but I might just pause, I guess, for 30 seconds to allow for some questions before we move on. Okay, I'm going to take that as a no. So in terms of manufacturing and industry, the industry sector we know accounts for a significant portion of emissions globally and is rising, having risen 70% globally since 2000 due to an increasing demand for industrial goods. In particular, the cement, steel, aluminium, and chemical sectors are major sources of industrial emissions, and their emissions and their demand are both expected to continue to rise in a net zero economy. In contrast to other sectors, the ability to reduce emissions from such activities is currently relatively limited. So if we compare that to the electricity sector, there are not, for a lot of the activities that we've included in manufacturing and industry, readily deployable alternatives where we can straight out say that you phase out or substitute one activity for another. Demand is projected to stay consistent and grow, on the other hand, and there are currently economic and technical barriers to really developing some of those alternatives, and that's very much influenced our approach to the manufacturing industry sector. The Future Made in Australia Act, in this regard, constitutes a really key pillar of Australia's drive to decarbonise industry and also realise some of those low carbon competitive advantages that we have relevant to the industrial sectors. Priorities under Future Made in Australia's National Interest Framework, which we've closely followed, include the manufacture of low carbon hydrogen, low carbon iron, steel, alumina, and aluminium, low carbon liquid fuels, primarily renewable diesel and sustainable aviation fuel, and also clean energy technologies. And we've been very specific about selecting activities and drawing criteria from those priorities, deriving them from what the highest emissions subsectors in the industry sector are, to inform some of those priorities, and then also drawing on some of the excellent research and pathways that are being developed by CSIRO, by Climate Work Centre, by the Climate Change Authority, and by the Australian Industry Energy Transitions Initiative to inform some of our decarbonisation measures. In terms of how we apply the transition methodology in this sector, we can very much say that all of the activities that we've selected have a stable or growing demand in a net zero economy in line with a 1.5 pathway. And for the most part, the activities do have material scope 1 and 2 emissions. There are instances, however, in which they do not and play a really foundational enabling role. So we have included activities like the manufacture of batteries, the manufacture of electrolyzers, and other kind of low carbon technologies as eligible because they do enable emissions reductions, and they're kind of automatically eligible under the green criteria. But for the most part, the manufacturing and industry criteria does cover activities that do have material scope 1 and 2 emissions, do not necessarily have low or zero emissions equivalents. And so in line with that, we kind of have green criteria for most of the activities in scope. And we also have decarbonisation measures, recognizing that some facilities may not necessarily be able to meet the green criteria in the short term. So we have to provide that suite of decarb measures that can be deployed to bring those facilities closer in alignment to the green criteria and the performance criteria, which is generally underpinned by emissions intensity thresholds that we have applied. So in light of that, this is the broad selection of activities that we've included. You'll notice that there are a lot of the higher emissions and hard to abate subsectors that are included in there. However, there are also those kind of low carbon economic imperatives that we've sought to include. So this is particularly pertinent when we're talking about the refining of copper, lithium, and nickel, which represent kind of future industries that Australia is hoping to seize, probably primarily in the 2030s, as value additive kind of midstream sectors that can add, I guess, downstream value to where Australia already has competitive advantages. We also have the manufacture of low carbon liquid fuels, as I mentioned before, noting that the guarantee of origin for low carbon liquid fuels is not out yet. And so when it is out, we will seek to align and consult with that where relevant for all of the activities in this sector. We have also included the manufacture of biogas and its upgrading to biomethane, recognizing its role or its growing role in a 1.5 pathway as stipulated by the IEA. And as I mentioned before, we've also included that range of a manufacturing of a range of enabling technologies, which are listed there, C12 through to C17. And one more thing that's probably worth pointing out on this slide is that we have also included a set of decarbonisation measures that can be used by industrial facilities that are not necessarily explicitly covered here. So recognizing that we have covered a high emissions portion of the industry sector, but not necessarily some of the other sectors that operate in the industry that contribute a lot to Australia's GDP. So whether that's food and beverage manufacturing or pulp and paper, we have sought to find what are some of the big levers that can help decarbonize those facilities and include them as eligible in the manufacturing and industry sector. And so we're really seeking feedback on whether we have got that right. In our consultations to date, we have been provided with evidence and feedback that that the measures that are included do cover the majority of Scope 1 emissions across a lot of those facilities. In terms of the criteria, and obviously given the depth and breadth of the sector, I won't go through all of them in this presentation, but we generally have kind of three components to the green criteria. So the first is the emissions intensity thresholds or technical thresholds, which we derive from credible reference scenarios that we use in Australia, and if not, then globally. If it's not available, then globally. We also have cross-cutting criteria. So where there is a requirement regarding the sustainability of a feedstock to mitigate any trade-offs or any other fuels that might be used in the production, there are kind of cross-cutting criteria which are requirements that must be met in addition to the emissions intensity thresholds or performance thresholds being met. And then lastly, we do have the decarbonisation measures if facilities cannot meet that green criteria. And they're quite exhaustive and have been drawn from the Climate Change Authority, the industry ETI, and a lot of other research that's been done from reputable and credible global and domestic sources.